Welcome to Week 5 of GIS 4630, Public Domain Data for GIS. Joseph Kursky here with you. Greetings. Let's talk about what we're going to do this week in our course. Now this week we're going to consider some important issues, including metadata and policies, and accessibility of national and state data. Now this week you'll have the opportunity to examine some national and state data portals and consider the issues of metadata. Now, as usual, we will be reflecting on your readings and the short activity that I will describe in a moment. Please read Chapter 5 in your textbook. This will provide some context and information about national and state data portals and metadata standards. Now, I know that metadata standards doesn't sound like a very exciting topic, but when you don't have metadata and you're trying to use data to make a decision, well, it becomes really critical. In the past, it was USGS, Census Bureau, United Nations Environment Program, and other agencies producing data, right? You and I were the data consumers. But nowadays, everybody is a potential data producer. And so with that opportunity of producing data and putting it in the cloud for other people to use, comes a responsibility that you need to also document the data that you're putting online. So think about that as we go forward. Also, you're going to access the data from the sites that I will describe in a moment and use it inside ArcGIS. So these sites are as follows. We're going to look at some hurricane data and reservoirs in Texas. We're going to basically assess whether reservoirs in Texas are at risk for potential breach with the dams that hold the reservoirs from a potential hurricane. So say that after hearing of your excellent GIS skills, the state of Texas has hired you to assess the risk of possible reservoir dam breaches resulting from hurricanes across Texas that could result in flooding. So what you're going to do is you're going to access the GIS data on the Texas Water Development Board's website. You're going to also access our hurricanes layer from the Louisiana Geographic Information Center. So this is a state GIS portal for Texas and a state GIS portal for Louisiana. And you're going to download and use those data sets. You're also going to look for hurricane tracks there. And you're going to bring the reservoir data and a base map from ArcGIS Online if you have time to do that, which won't take more than a moment, but you want to make sure you've got a sufficient bandwidth, and the hurricanes data. And I want you to answer the following questions, some from the readings and some from the hands-on activity. From the readings, select two issues surrounding national and state data portals and describe them. Then describe the Texas Water Development Board's reservoir data and the Louisiana Geographic Information Center's North American hurricane data that you downloaded, and indicate the data model, the file type, the date range, the ease of downloading the data, and also think about the hurricane's data. Is each segment 6 hours for one hurricane or 1 day in the life of the hurricane, the complete life cycle of the hurricane? I really want you to, through these kinds of questions, not get into the specifics of the question so much, but think about why I'm asking that. The reason why I'm asking is I want you to understand your data. I want you to know your data. Be your data. Know your data. Right? The point is that unless you understand the data that you're using, you're on shaky ground. You're on unsolid ground there, because you don't really know what goes into making your decision if you don't understand your data. Also, think about the map projection. Is it the most suitable one for the analysis that you're doing? And describe the pattern of hurricanes. What are a few reasons for the patterns that you see? And then determine the percentage of reservoirs in Texas that are within 10 miles of the hurricane paths, and describe the procedures that you used to determine the answer. Also this week, you're going to start a new lab exercise which has to do with siting a fire tower in the Loess Hills of eastern Nebraska. Those hills are continental wind-blown silt from glaciation. They're also in western Iowa. Beautiful place, and I encourage you to take a field trip sometime. But you're basically going to be downloading data to site a wildfire observation tower in the Loess Hills. And as usual, there are numerous work packages that it's broken up into, and questions that I pose on the data, on the patterns, on the tools that you're using, and so on. So you're going to locate the best sites for locating lookout towers for firefighters to spot wildfires, and to be used as a location for base operations for fighting wildfires in the Loess Hills near Blair, Nebraska. And much of the terrain is covered with medium-length prairie grass. Now the study area will be the 7.5 by 7.5 minute cell that corresponds to the 1 to 24,000 scale USGS topographic map in which the town of Blair is located. So we're going to download some digital line graph data, which are vector data sets, a digital elevation model, national land cover data, and you're going to create some derivative data from those data sets. And you will further analyze these data sets to choose the best location for your fire towers. Now, the criteria for the fire towers are that they must be as follows. 1, within 100 meters of a roadway for easy access. Number 2, within 200 meters of a river for access to water. Number 3, at or more than 380 meters in elevation for the best visibility of the surrounding terrain. Number 4, on a slope of less than 5 degrees to minimize construction costs and maximize ground stability. These loose hills are they're solid, but if they're steep, they're easily eroded. Also on range, pasture, and grass land cover, since these are the areas most susceptible to wildfires in this area. And so the skills required, you're going to be required to think spatially. You're going to be required to use file management skills. Background in GIS is very helpful once again, but enough screenshots are included as to make this exercise fairly self-explanatory. So you're going to download data, you're going to manage files, you're going to clip, you're going to merge, you're going to symbolize, you're going to classify, you're going to analyze. So that is, in essence, what we're going to be doing in this week in the lab exercise. I hope you enjoy it. I hope you find it valuable, and we'll see you online. Thanks.